So in this video, we're going to have a look at calculating molar concentrations. So molar concentrations are going to be the number of moles dissolved in 1 liter of a solution. So when we are looking at concentration, we are going to look at how many moles there are in 1 liter of our solution. Okay, extremely important here. This is liters, not milliliters. Okay, so we can't be measuring concentration in anything but moles in 1 liter. Okay, now the unit of concentration, so is moles per liter. So this is a unit, but it's also called in words, would help if I spelled it right, molar concentration, or we can actually use a large capital M to represent molar concentration units. Okay, so each of these three, so moles per liter, or the word molar, or a big capital M, are the units for molar concentration, and they are interchangeable with each other. So you can use one or the other or the other. You don't have to use just one specifically. You can interchange them however you want to. Okay, and just keep in mind that they're always going to be interchangeable. So if you see moles per liter, so MOL /L, that's moles per liter. If you see molar, or if you see that big capital M, they all mean the same thing. They're all meaning molar concentration. Okay, now for example, so we could have the concentration of sodium chloride is 4 moles per liter, or we could say 4.0 mole per liter, or we could say 4 molar. Okay, and again, all of those are equal to each other. All right, now one other reminder is that when we're talking about concentration, we can actually use square brackets to represent that word concentration. Okay, so that means if we say the concentration of sodium chloride, that's the same thing as writing NaCl with square brackets around it. NaCl with the square brackets are going to mean concentration. Okay. All right, so when we are trying to calculate molar concentration, we're going to take the number of moles divided by the volume of our solution. Okay, and the unit for moles we know is MOL. The unit for volume that we're going to use here is going to be liters. Okay, and so that's going to give us our molar concentration in moles per liter as our concentration unit. All right, so we're going to start with some examples here. So example number 1. We are going to have a sodium hydroxide solution. So we have sodium hydroxide has 0.186 moles in 250 milliliters of solution. So we want to find molar concentration. Okay, so with this solution, our concentration is what we're looking for. And so we have 0.186 moles, and we know that the volume is 250 milliliters. Now, the first thing that I want to do is convert my milliliters to liters. So 250 milliliters is actually 0.250 liters. So just a reminder about that conversion, 1 liter is 1,000 milliliters. Okay, so if you're going from milliliters to liters, you want to divide by 1,000. So our 250 milliliters turns into 0.25 liters. All right, so to calculate our concentration, we're going to do our moles divided by our volume. So we have our 0.186 moles, and our volume is 0.250 liters. And so we're getting a concentration of 0.744 moles per liter, or 0.744 molar. Okay, and again, don't forget those mean the same thing. Okay, moles per liter, or that big capital M, mean exactly the same thing. All right, so that's relatively easy. If we know the moles, we know the volume, we can calculate the concentration using one very simple calculation. Now, we don't generally know the moles of a substance when we're dissolving it in solution, and so usually we're measuring the mass. So this next example, we're going to start with the mass of a solid, and then we'll dissolve it in our solution, okay? And then we're going to be able to calculate its concentration. So we're dissolving 30.46 grams of silver nitrate in 500 milliliters of water. And we want to know what's the concentration. All right. So the first thing that we need to make sure that we know is that our silver nitrate is AgNO3. It's super important that we're able to write formulas now. And so if you need to go back to refresh your memory about writing formulas for names of specifically ionic compounds, please go back and do some practice with refreshing that, because if you can't write the formulas, then you're not going to be able to find the right molar mass, and that's going to take your entire question off track. All right, so we have silver nitrate, and we have a mass of silver nitrate, and we have our volume. Okay, now concentration is moles divided by volume, which means we need to turn the mass of silver nitrate into the moles of silver nitrate. So we're going to start with our 30.46 grams for silver nitrate, and then we're going to multiply that by our conversion factor to turn it into moles. So for silver nitrate, we know 1 mole of silver nitrate is 169.88 grams. Now again, that 169.88 is the molar mass for silver nitrate. So there's 1 silver, 1 nitrogen, 3 oxygens. So that gives us a molar mass of 169.88 grams for 1 mole of our silver nitrate. So when we do that calculation, we get 0.1793 moles. Okay, and so then we're able to calculate our concentration. And so concentration is going to be 0.1793 moles divided by our volume, which remember to put in liters, so it would be 0.500 liters. So then when we do that calculation, we're going to get 0.359 moles per liter for our silver nitrate. Okay, so in this example, we had one extra step at the beginning of the problem because we needed to go from our mass to our number of moles. We need moles to find concentration, but we already had the skills to be able to find the moles if we're given the mass. Okay, let's try one more example where we're going to do that. So in this next example, same thing. We're going to have so this is another example. So 1.68 grams of copper 2 sulfate. So copper 2 sulfate is CuSO4. And 150 milliliters of water. And we want to calculate concentration. Okay, so for our copper sulfate, we first need to find our moles of copper sulfate. Let's do this in red. So we're starting with our mass of copper sulfate, 1.68 grams. We need to multiply by our 1 mole of copper 2 sulfate. It's going to be 159.6 grams. Again, that's our molar mass for copper 2 sulfate. 1 copper, 1 sulfur, 4 oxygens. And so when we do that, we get our moles, 0.0105 moles of copper 2 sulfate. Okay, and so then to calculate our concentration, we're going to use our mole value, 0.0105 moles. And we're going to divide by our volume. Don't forget to put our volume into liters. Okay, so we've got 0.150 liters. All right, so then when we do that math, we get 0.070 moles per liter as our concentration for copper 2 sulfate. Okay. Now, we can also rearrange, and we can use our concentration and volume to find how many moles, or we could use moles and concentration to find the volume of our solution as well. So we can always rearrange this equation. And so when we're using this concentration equation, we actually use some letters to represent the equation. So we use C is equal to N over V. And so in this formula, our V is, of course, for volume, which we know is in liters. N stands for moles, which the unit we know is MOL. And then C stands for concentration. And we know that that is moles per liter. Okay, so if we're trying to find moles, moles will actually be concentration times volume. Or if we're trying to find volume, volume will actually be moles divided by concentration. And so that same formula can be rearranged in multiple ways depending on what we have and what we're trying to find. So if we're trying to find concentration, we do moles over volume. If we're trying to find moles, we can do concentration times volume. If we're trying to find volume, we do moles divided by concentration. Now again, do not forget, make sure everything is in the correct units. Moles for moles, right? Liters for volume, mole per liter for concentration. Okay, so if we try an example where we know the concentration of NH3 is 14.8 moles per liter, and we know we have 1.50 liters, how many moles is that? Okay, so when we're trying to calculate moles, let's do this in red. Moles is going to be concentration times volume. So we have our concentration of 14.8, that's in moles per liter. And then our volume is in liters, 1.50. So we get moles of 22.2 moles. Okay, and so you see how we can keep rearranging this equation depending on what we have and what we want. Now, if I then asked you for the same problem, how much mass is that? Now we know that we have 22.2 moles of NH3, and we can convert that into a mass. So our 22.2 moles of NH3, if we want to convert that to a mass, we use our molar mass calculation. So for NH3, it's 17.04 grams in 1 mole, and so that's going to work out to 378 grams of NH3. So we can use this concentration equation with our mole and molar mass conversion factors. Okay, so we can use this back and forth with all of those conversion factors, depending on whether we are starting with mass or whether we are ending with mass. Any of those are a possibility. So that's it for this video on molar concentration. There's a bunch of practice for you to work on in terms of calculating molar concentration. The most important thing is make sure that your substances are in the correct unit when you're using this equation. Okay, you cannot ever use volume in milliliters, but volume is often given in milliliters. So make sure you are converting it to liters before you're using this formula.